style of presenting is kind of different, but I think it's actually aligned with like what we are trying to do here as a community. So I actually thought about that a bit, and like it's what I'm doing usually. I'm not trying to give you like excessive amount not of knowledge, but rather some frame of understanding the concepts, and then like giving you resources to get that detailed knowledge later to fill up that frame. I think this works because like I can't make you Docker master in like an hour. I can explain what it is, how it works, and give you some examples, and then point you out to some tutorials to help you build that knowledge. But uh yeah, so this is kind of style of presenting I do. Also, I don't have any like presentations or something because there's a lot of resources. So I have more or less just references, some web pages, and examples that I can show you. So that's about it, but we'll see how it goes. Anyway, for the Docker specifically. So uh, first of all, I don't know what level I should begin with because we can go really, really deep, but you don't need to have such deep knowledge to use that. But let's see, and let's see how it goes. And you can always ask the questions and everything, because that's also like part of this like community experience that you can ask if you don't understand anything. Anyway, so to understand Docker, let's start with a little theory. Let's go a little deeper, like for understanding the concept, and then we can build up from that knowledge, ground up, and then I can show some examples and stuff. So, first of all, containers. Uh, Basically, the base Docker is composed from two base parts. One is containers, and second is images. We will get to the images later. Let's start with the containers because that's the main concept. So, what is container and how does it work? Well, uh, containers are like based on actually functions in operating system that helps you to like run processes in isolation and let's say allow or deny access to different resources for those processes. That's basically container. Like it's mm, people offer like do this reference. Imagine you have like virtual machine, and what you can do, you can say, well, I can allocate like the host operating system resources. Let's say I have 4 cores, 8 gigs of RAM or 16 or something, so I can allocate 2 cores and 4 gigs of RAM, and run some virtual machine, and that machine will be on the host system like completely emulated. So for it won't know that it runs on some other system or anything. It will be like emulated under the hood, and it thinks it runs on a bare metal. So I can install their second operating system, so I can run like virtual machine with Windows on Linux or vice versa and so on. And it's like machine on its own. But the container is a little bit different. People usually say it's like lightweight virtual machine, which is not entirely true, but also like for the base like using it kind of is. What it does, it's starts some like process on the host operating system, and that process is started in isolation. It means it can see or use some resources of the host operating system, but it still runs within that system. So like the base layer of, let's say, operating system stuff is shared across, all the containers on that same system. And uh, now you may ask, how does that work, running containers on different system and so on. And the fun part is that, like, the containers actually start, there's several things about containers. First of all, they started on Linux, as these things usually do. And they basically use, like, Linux, like the kernel functions, to start processes in some mode in isolation. Like, basically, I actually saw a presentation where the guy, like, in 2 hours built his own, let's say, Docker or like containers in C++, basically, starting processes with some flags and so on, like through, kernel on Linux, and basically started his, like, own processes and everything. uh and that brings me also to another point, that Docker is not only service for, like, running containers. There are others, but it's the same thing, like saying, Git is not the only, versioning system. There are others. Yes, there are, but 95% is covered by Git. So it's basically kind of similar with Docker. So there are other, containerization systems than Docker, but, like, majority of stuff is run on Docker. And we will get to the, like, details later about why is that and so on. But, like, the containers themselves basically use just some functions or features of, like, kernel, and start, like, processes with some settings and so on. And Docker utilizes that and gives you basically declarative approach, where you can say how the process should start, what permissions and what access to resources should it have, and so on, uh, in a declarative way. So you can say, well, you will have, this amount of RAM, you will, have, like, exposed this networking port and so on. You will share this file system part with the host operating system and so on. You can say it, like, with simple command, and Docker under the hood goes and starts the new process with this setting, in the host operating system, and container is alive. So nothing over complicated. Now, one question you might have is, how does it work on Windows or Mac? And this is actually pretty funny because where oh, hello, Mimi. We are having a presentation on, or like a monologue so far on on Docker. Uh, okay, so anyway, so how does it work on other operating systems? Uh, well, first, where when the Docker, like, came to be and starting to be really popular, people, like, demanded to run it on other systems as well. So first, what, like, Windows and Mac did was that they started, like, virtual machine with Linux, like, behind, and started those Docker processes in that virtual machine. Because that was the easiest way, and it was actually super slow. But later on, Windows was actually first in this. They built their own capabilities to their, like, operating system. So Windows, like, in its core now supports the same stuff as Docker. So Docker can run there. Uh, but funny thing, you can have Windows containers that are not based on Linux but based on Windows. But you cannot run, like, Docker, like, Linux and Windows based containers at the same time. You need to, like, switch in the core, with which stuff you should use and so on. So it's kind of funny and long story, but that's how it was. And later also, like, Mac adopted the with new version of their OS, they adopted the Linux approach. So now on Mac you can start the containers, like, on the hosting system as well, like, not in the virtual machine. So that's basically how it came to be. So now, like, containers are basically just, processes. It's all based on operating system. So there's that. And now you might ask, okay, so what did Docker, like, bring extra. Of course, there's this declarative approach that you can simply start some container, fine. But what Docker did, and what like bring it to the next level, and why it became so popular, are actually it's actually the second part, and those are the images. And what Docker did, they said, well, we need to start some process. It can share like the base layer with the operating system as a like isolated process, fine. But how do we say which process, which libraries should be there and so on? Because like the host system like doesn't have everything. Those processes might be some need some other libraries and everything like installed. So but we don't want to install that onto the host system, to be able to run that process in there. So what they did, they introduced images and a layering system that allows you to adopt like file system layers with adequate like files, libraries, configurations, and so on, and build like replicable images which allow you to start those processes. So what they did is basically they said, okay, so we have the base. Now we will run install command just for isolated file system of that process. We will do file system isolation as well. So they introduce volumes and stuff like that. So we will create like isolated file system in the volume. On the host system, it appears only as a single file, but inside is another file system. And in there we have access, for example, to tools that the host system use for like installing packages. Or we can, for simplicity, we can just copy there some files and build on top of the like host system. So we can copy there like libraries, we can copy there some configuration files as we would install them and so on. We can compile them, we can compile stuff and put it there like to the volume and so on. So what they did, they built this layering system. And why layering? Because let's say in the next layer we will just install some libraries, which means like creating separate like file system layer and copying there like all the files, libraries, and so on that we need install. Then we will create another layer that will install or do some other stuff, another layer, and in like fourth, fifth layer we can finally run this process with all those files and everything. So we can have like layered system of things. And it why is it layered? Why is it important? Well, you can do like extensions and branching and stuff like that, because you can go to any layer and extend it in different way. You can copy just those base layers and create like completely different like uh, image just based on that, and so on. So you this gives you like big flexibility to, let's say, putting those images together. And uh yeah, so that's what Docker did. That not only it allows you that system containers, but it allows you to build like pre-build the images through the layers. And what is also maybe the most important part, to share those images with others. So let's say you create that image to run some process with all its dependencies and everything, and you take that image and you can copy it to somebody else, and he will do, okay, Docker, run this image, and Docker will read that image and start that process according to that image. That's the really important part. So you can now have one image and you can start processes or containers from that image, and you can start many of them and so on, because they run in isolation. You can start many processes and so on. So this is the base idea, that now we have the images, we start those containers based on those images with all those configurations for the isolation and everything that stays. But also the configuration from the image is basically copied there. We can create our own images, we can share them, etc. So we can like build our own app and have it pre-configured and everything. We can store that into the image, and we can share that image with somebody else, and he can just with one command run that app through the Docker image. So that's the powerful thing, like sharing those images. And of course, what happened is that Docker basically introduced Docker Hub, which is like public repository where, same as GitHub, public repository where when anyone can go and share their images with others. And you can download that and upload that from the internet. So you can then say, I want to run this image, and Docker will say, well, I don't have this image locally, but let me check, if Docker Hub has that image. Okay, it does. I can download it, and then I can run it and start it as a container. As easy as that. Yeah. They are like it really depends on the base layers, but usually what happened, and what is happening, is that somebody created, like, let's say, base images that are basically based as some really, say, low config of operating system. So the base image, for example, has, like, I don't know, 200 megabytes, and it's like, the base layer of the image is like 200 megabytes, and it has all the libraries and configurations for some really small, operating system, like functioning in its own. And then anybody, because it's layered, anybody can go and start from this layer and build on top of that, on that operating system. So then you can use, like, the package manager of that base operating system, to install other stuff, which creates another layer, and then you can, install your application or copy files of your applications in there, and then you can start it, and all of these steps create like separate layers in the image. And you will see it in the example. Yes, there are different flavors. You have base image of, like, whole Ubuntu without GUI. You have base image of Alpine Linux, which is like 80 megabytes. It's one of the smallest, which is like really bare bone, like Linux kernel with only few things added, and so on. And you can start basically from where you want. And for example, a lot of those like popular images that are like maintained, for example, I don't know, some database or Python or something, they usually have like different flavors of those images that differ in size and capability. So for example, you can have a really small like image for Python based on the Alpine Linux, and you can have like really big image based on Ubuntu. And the difference is, like, you want small image, fine, but you might not have every, operating system library that might be required by some Python dependencies that you might use, and so on. So you will need to build that up yourself, basically. Or you can use some bigger base image which has most of the dependencies installed already, but you will, pack them. So you can choose, basically, then, even for the same, thing, you can choose different images uh, based on their, base layer and operating system they run on. But they are all Linux based, except those Windows images, but that we don't talk about. Okay, so let's go check. So this is the Docker, the two main parts, like containers and images, and also there is the Docker Hub for, sharing those, let's say, images publicly. And you can build your own images that are based on some other images, uh, based on the layer system. So there's that. And so, yeah, that's basically all you need to know. So now you need to know, let's say, Docker commands. same as Git commands. So you can, run those containers, do some settings, build your own images and so on. And as same as with the Git, you can use the, terminal, which is like the native way, or there are GUIs, that are built on top of, the terminal interface and so on. Same as with the Git. There's a lot of similarities, like in this. So let's check it all out now with some examples. So okay, so first of all, you go to docker.com, which is like the base page, and first thing I noticed, they have broken the they have broken like the cookies acceptance thing. I don't know, for some reason. So let's fix that, because I really hate this. Yeah, this is the fixed position. Yeah, something like that. Okay. Anyway, this is the Docker page. There's some fancy stuff. Okay, it runs a lot. Blah blah blah. Yeah, there's the thing, like, you can build those containers, you can share them, and you can run them. That's those main part I was just talking about. And yeah, they have community, everybody uses them, blah blah blah. So fun stuff. They have a lot of products. They have also paid version, like the Docker, because it's based on the Linux or stuff like that. It's like the Docker itself, like the command line tool and everything around it is free. But like the Docker Hub, for example, if you want to have private images there, you can pay some subscriptions and so on. If you want to use some of that GUI, you should pay some subscriptions, and so on and so on. So they have some monetization model as a Docker company, but the base stuff and command line tools and public images, it's free. So yeah, again, similar with GitHub and such. Okay, so there are the features. Let's yeah, let's start with the documentation. Or yeah, so of course you need to download and install the Docker, and you can either this as well. You can either like install the command line tools, or now they have the official GUI for every distribution. So you can go with the GUI. But yeah, um, that's what it is. Yeah, and by the way, yeah, in the overview you can read all the stuff I told you already. So this is like the architecture, like that. You have the images, you can pull them from some Docker Hub, or some other registry. Same as like with the Git, you can have private repository somewhere on your own server. You can have like private Docker registry somewhere where you can push your private containers, and so on. So you can pull the images from some sort of registry, and you can start them, and so on. Basically a couple of commands, and you got this. Yeah, so it's the fun stuff. Here's the example how to run Ubuntu locally. So very simple. You just say, I want to start Ubuntu container, and I want to start like bash there, and that's it. Yeah, exactly. If it but it needs to be installed in the container. But yeah, you can start other stuff in the container, and we will get to that as well. Okay, so yeah, so this is getting the Docker, getting started part. Yeah. So yeah, this is funny thing, like how you can, you know, run and start your container and also expose your port locally and some other stuffs. Applications, yeah, how you can pack your own applications and so on. So there's there is several things, but yeah, this use okay. Okay, so um now you know where to go. You can read all of this. There's a lot of things around those containers. um I think there was actually nice guide for like manual installation. Mm, what if I want installation, let's say like this, yeah. So you can install it just as a command line tool, which is nice. No, this is I don't want Docker desktop. I want just Docker engine. Yeah, so that's the thing. Like Docker desktop is the GUI, Docker engine is the base stuff. Docker hub, will go there. That's the registry, and Docker compose is, let's say, another tool built on top of the Docker, which we can check later. So uh, let's go here. And let's go Debian. Yeah, so this is how you install just the, yeah, and this is what I wanted. So let's try some simple example, which is basically to check that you have Docker installed. So let's go to the terminal. I don't know if you can see this, so let me. Yeah, good. Okay, so basically I have like Docker installed, simple stuff, and now I can run this. And there are several things what it will do. So this is like the command run. You can find like documentation uh, for it, like reference documentation for every command. So there are all the options and things like that. So read it up. But basically, I'm running container hello world. And what will happen now is that it will check for the container if it exists here or not. If not, it will download it and so on, and it will run it. Okay. One important thing, you have, let's say, tags or labels of those containers. They are used for different to, like, the name is the primary part. If you don't use any prefix, so you can use like different repository as a prefix. If you don't use any, it will go to Docker Hub by default. If you have some private Docker repository, you would write it here like this, private, slash something. This is the image name. That's the important part for the image. Okay. Sorry. And then you can have like text, so you can say there, I want hello world version 1.0 or something like that. But if you don't specify anything, the default, same as the default branch on Git is master, the default tag on any Docker image is latest. Basically, download me the latest version. If it's also divided by different, bases or something, like the latest version basically should fall under one of those versions, like the default one. So I'm saying, run this container to default stuff. And what will happen now is it will write me, I cannot find it locally. So I'm pulling the stuff, and this container only has one layer. So each layer is hashed, has its own hash, same as each commit in Git. Again, the reference. So it pulled only one layer, and then it ran the process, and this is basically just it was downloaded, and then it was run, and only thing that it did is write out this message, and then it quit, and yeah, we are done. Super simple stuff. Well, now what you can do, you can for example check the images that are downloaded locally. So this image is actually not based on any operating system. It has only 13 like kilobytes. It's like super small. It's only writing the message on the output. So you don't need much for that in this sense. So super simple. We could try the other image. Let's say the right. So this is actually saying, okay, run the latest Ubuntu. IT is like interactive mode, so I could write and read input and output from the container. I need to specify it because of the isolation, and this is overwriting the default command of that container that I want to run and the bash. So let's go. I cannot find the Ubuntu latest here, so I'm gonna run it. And now you can notice that it I at least I think it should not look like multiple layers. Maybe not. Okay. It's also optimized for one layer. Usually those base images are only one layer. By the way, I'm in the container, so yeah. So now I'm logging as a root, and I'm inside that container. So nothing much is running here because I'm just inside the container. So nothing here, I guess. Yeah, fun stuff. So I can check how so I have new image, but I can also check what containers I have and that are running. There's also flagged if I want to check containers that already existed, I can list all. But like this one, that was the one we ran and already exited, and this one is still running. Funny thing to check out is actually the processes, but yeah, it's a classic. Uh, okay, and let's start some stuff. So if I search for, yeah, here it is. So here is the process, and here's actually the thing that is running in the separation, like under the terminal. But yeah. So anyway, there's a lot of processes like associated with Docker because it does its own thing. But okay, so this is just some base stuff. So I'm inside that container. If I quit it, I'm done. So no Docker process is running. Two that exited a couple minutes ago, and yeah, those images. Also, volumes. No volumes. Don't know how to list. There was way how to list like all the shared file system layers, but that's not important right now. Anyway, so this is like the base of the Docker, and now last thing I want to show you is actually the Docker Hub. So it's on the hubdocker.com, and here you can have account and stuff like that, so you could push their images and so on. But the main thing is like you can find all the images there, like the trending stuff and everything, Node, Python, Nginx. So we can, for example, open Python and things like that. Maybe, I don't know, Postgres or Mongo or whatever. And yeah, so you can find, oh, by the way, if you don't run the image, you just want to download it and use it later, you can do just Docker pull, and then run it later. And if it's already downloaded, with the pull, you will just run it from the local image. And by the way, okay, so this is the Python. There are also like official images and unofficial ones and so on. And there's usually some descriptions and there's list of tags, and you can check like okay, so this Python latest image has like all these layers, or all these like flavors based on the systems. uh there's also some alternatives. There are version 1, there's like Slim, there's like lot of stuff, different version of Python, and so on. It's like all tagged. Then there's some reference. So there's like Python image for different architectures. Yeah, you usually use separate containers. Like what you could do is like download and like connect to the Ubuntu container. In that container, install Docker, and in that Docker, inside that container, run another container, for example. But like you usually don't do that. You just run multiple containers at the same time, and that's it. So yeah, and there's also the same thing for example, Postgres and so on. So this is like the container registry where you can find all your containers and stuff. Two more things I want to show you. First of all, there's the let's say the GUI version. I have it installed as well. So you can see like you can see like the exited containers, and you can see the images I have locally and so on. Basically the same thing as you have in the command line, you now have with this GUI. You can run the container here, you can set up stuff and so on. So funny stuff. So for example, I can delete those old stopped containers, and I can, let's say, clean up all unused containers. And you can do all of this with commands, but just to show you that the GUI exists, and you also have some references for the latest stuff here. Yeah, and volumes and things like that. So this is the GUI, and you have also extensions and like lot of stuff basically in here. So this is all nice. So how is the Docker used? I talked about it previously, but let's say you want to run the database, Postgres, Mongo, something. So You can install it, from the source. You can compile it. You can do whatever, or you can go here. You have Docker installed, and you can basically say, well, I want to run uh, some uh, database locally. So I will copy this command, and I will go to my terminal. I will put there the command. Yeah, we can do this. Yeah, and I will run container Postgres. It's gonna be the latest. I can name it. It's also useful that you can name your local running containers, and then reference them by their name. Otherwise, you can reference them by their hash, or if you don't name them, they are given some randomly generated name, but you can name them yourself. You can pass them environment variable. So I'm passing this variable, and this is the D is that it's starting like in the background, like separate process, not connected to this terminal. So let's do this. Postgres is not installed locally. So again, I'm gonna download, and now you can see actually that Postgres has like multiple layers. So I need to download all of those layers. And first I download them, then I'm extracting them, and I can download them like in different order, but I need to extract them at the same order they are. Uh, mm, they are meant to be put together, obviously. So stuff, yeah, and Postgres should be running, but I forgot one really important part. I forgot to expose the port, so now I can't connect to it because the port is uh well, maybe not. Maybe it has the configuration that it exposes the port default, right? uh Probably does. Yeah. Okay. Well, we'll see. Well, and funny thing, what I can do, I don't have Docker client installed neither. So I can uh I can do funny thing. I can start the second container with the Postgres, but this time I'm not starting the default command, which is the instance, which is the server, but I'm overriding it with like Postgres client to connect to Docker. I will use localhost. I will use this. I don't have any network setup. I want to remove the client after it's exited. I want it to be interactive because I need to communicate with this. It should be fine. It should ask me. Okay. Yeah, so I forgot to open the port. Never mind. So I'm gonna stop some Postgres. Nice. I'm gonna remove some Postgres. I'm gonna start again, this time with port exposed. This is because the containers are running in isolation. I need to say what needs to be exposed. It started already because this time I'm in no need to yeah, and I need to put this before, because otherwise it's not gonna be will be passed as a parameter to the container, which is bad. Cool. So it's running, and now the ports are actually exposed, which is cool. So now I should be able to connect to it. Nope. Uh, why not? Yeah, I probably know why. Because um it's in the wrong network, right? Yeah, it's gonna be yeah. If I'm gonna yeah, if I'm gonna be able to find it. Like what we did is this. Um, but, uh, how was it? Network. But this shouldn't be. Um. Oh, I know. I know. This is fine because uh, this actually starts the process and exposes the port to the host. But this is a problem because it doesn't run on the host network. So localhost for this container is actually it's actually different network because it's the container itself, not the yeah. And I'm there on stuff. Now I need my secret password. Uh, and I'm there. So voila, I'm now um, I have now two containers started. One is the server, one is the client, and now I can do SQL stuff in here. So I have only default database and stuff, but works. Yeah, and this errors and stuff, it's actually like good because it shows that the containers are running in the isolation. I needed to say I need to expose the port to localhost, to the host, and then I needed to put the client to the same network as the host. Otherwise the local host is like different. What this does is says like this process is running on the same network as the host machine. So then the local host is actually like my computer, but otherwise the local host is some network bridge inside the like specifically for this process because it's running in the isolation. That's the fun stuff. Okay, so this is basically what you can do like with the so I can now quit it and I can after myself can do that later. Anyway, so this is how Docker works. I hope you got this. This is like the Docker hub where you can find the images. You can find all about Docker and how to do stuff, what I showed you, basically all the commands and everything, you can find it in the module. Only thing we haven't shown, I haven't shown you, is how to build your um, own images, because now you can start the containers, you can pull the images, you know how to find the images theoretically, you can run the commands, or you can use the GUI. All fine. What you don't know is how to build your own image, how to for example do some application and put it like together. Well, for that you need Docker file which describes how to build your image, and it can look basically like that. So you start, and this is all like referencing, to commands, and I will not go into the detail, just for a note. You start basically by saying from what kind of image you want to start. So here you can specify, Python, whatever image, or just some the basic stuff from Ubuntu, and version and so on. So this will be your base layer. And then you can either run commands or copy stuff, or do some changes. You can export from the container. You can basically do all the setup of your container. Then you build it with the build command, and then you can run it. And then if you want to push it, you need to log into the Docker Hub or your own registry and do Docker push and push it there. But yeah, then you need to learn all these commands and stuff and so on, basically to build your own image. You start from some layer as we described, and then you go from there. And the last thing, very last thing I want to talk about is actually which is here, which is some extra tool above the Docker. You need to install it separately. So you have Docker, and then you have like Docker Compose, and what Compose allows you to do is basically this. Imagine you need to, start the database, then start your app, maybe start other things, whatever. And your commands that you run, individually and so on, became this, and basically for every container that you need to start to run your application. So basically, yeah, you are in control. You can start the database, you can start your app, you can do the containers, everything. But like hell, that's the command. So what you can do is create a file for Docker Compose, which is basically defined in YAML. It's like configuration file. So you define just version of the compose, and then you define all of those configuration parameters that you pass in here. You define them like this. And the like big advantage is that you can do it for multiple containers. So then it looks like this, you know, one container, other container, all the configurations, everything. But then you can just go to the folder when you have your Docker Compose, and you just run Docker Compose up, and that's it. And all those containers in their defined configuration are started. So basically, the Docker Compose is just a simple but powerful tool how you can summarize all your configurations for all your containers. You can version this file to Git, you can push it, somebody will just pull this configuration and run this command, and everything is up and running for them, including database and other stuff. They don't need to install anything, just to have Docker, and you are good to go. Yeah, this is running like two containers from two different images with like different setups. So basically, if you have like Python and then Vue, you might have one container that is able to, start your server, and run the Python, and then second, container that can run the Vue compilation and yeah, and run the Vue part. And they can be in the same network. They can, you can share your volumes with your host system, and you can basically do development setup. When somebody new comes, they can have like completely clean installation of, operating system, everything. No need. They just install Docker, they clone your repository with git clone, and they do Docker compose up, and everything is up and running. No installation needed. Yeah, you can, like, you usually build those images in the way that you either have like those volumes that can be like shared file system that is changeable, or you have your code like copied to the image, and then it's like fixed layer in the image directly. So usually for development, you do the volume just to have the, Python installed like in the environment, and the code is like dynamic in the volume. And then you build the final image when you're releasing. So you say, okay, start from Python, now copy all of this into the image like permanently, and release it as my app, version 1.0 something, and then publish that, final image somewhere. Those are like two modes. You can use the Docker for like local development, and you can use Docker for like running your production, like publishing those application versions and so on. Yeah, I hope so. That's the frame of understanding. You need to make the connections and like understand the concept, because all of those videos, they usually explain like, you have containers, you have images, pull images like that, you run container like this, and then you can do this with the containers and so on. And they don't tell you like what the container actually is, and how it works and so on. Yeah. 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 I think that the puppet is okay. I don't know puppet, to be honest. So like software that ensures our systems are configured to user preference. Okay, distinct configurations for systems. Well, yeah. I think it's like they have some similarities, but I think the main concept is like different. Puppet is like configuring your like running systems or VMs or whatever, like to have the same config. Their Docker just runs like separate processes, no matter what system or stuff is underneath. So there's like a really key difference in the functionality. I think the article sums it up nicely, what I can tell. Uh, well, it's above the Docker. It's like for containers orchestration, and it's actually independent on Docker. You can run Kubernetes with different containerization like systems, but you can use Docker in Kubernetes. That means that you have like Docker and those images from Docker, and Kubernetes can like pull them and run them, and that's it. And then it does the orchestration. That's like the thing like I said, you can say I want to run 10 of these containers, and Kubernetes does that, runs tens of those containers and put automatic load balancer between them for traffic, for example, and so on. No, it's actually like for what you do for Kubernetes, you say, well, I want to run like Kubernetes cluster, which consists of several like virtual machines or servers or whatever. And what it does, it says it's like for another whole presentation, but basically what it does, it says, okay, there's one master server, other servers are slaves, I know what their health is, I know what their power is, I will distribute containers that I need to run throughout those servers, and I will balance the traffic there. And then it like pulls images of all containers it needs to run. It will run them, do the configuration, run them in the count that you need. So for example, Python Django 10 times, Postgres 2 times when one is master, other is slave for replication. And then you will, connect them to the same subnet. Then you will do the load balancing between the Django instances, and you will scale up and down depending on the traffic, and you will replace the faulty Django containers. For example, if there's some error with the new ones, you will kill the old one, do their new one, and so on. And all of this is managed by Kubernetes automatically. It's like whole system like around managing containers and working with them. No, no. And Kubernetes actually dropped like the support for like Docker, like officially. It's like multiple container systems, so you can use a different type of containers, not only Docker. So, and it works like on different level using different like concepts from networking and connecting different servers. You can have like Kubernetes cluster through different servers. Some of them may run in the cloud, some of them might run in the on-prem, and you can you can do really crazy stuff with that. Like it's really a big playground for all the DevOps guys, and you know who wants to configure their stuff. Yeah, yeah, you are very welcome. My pleasure. By the way, like we use Docker and like Docker Compose, especially basically for every project that work. It's must. And we sometimes deploy to Kubernetes, sometimes to different services, but usually in some form of containers and stuff like that. So it's really used in practice like a lot, especially when you develop like on cloud and when you want like easy local development. It's definitely recommended. That's that's enough. Mhm. Mhm. It's a added value. I probably would reference them to different position if they like applied, for example, for like developer, I don't know, front end, back end, whatever, and they have like strong, let's say, DevOps skills and system administration skills. I would apply them for I would say, like it's good. I get you want to be like backend developer, but you can be like junior backend developer, but you could be, let's say, middle or even senior, like DevOps engineer or something like that. Why won't you apply that there? You have those positions as well. Yeah, so that would be like the senior in my current firm. Because and if they say, well, I want to be junior backend developer or whatever, I would say, okay, that's fair. Like you want career change or something, it's fine. But that would they would be for evaluated on the level they are as a developer. This would be like nice bonus, for example, like the DevOps part. But uh yeah, the main evaluation is still on the developers, like development skills, if they are applying for developer position. mm, I would say that definitely helps them. Mhm. Like from this, like, I had several conversations even here. I think like it it depends on the company and how they evaluate their candidates. Like, for example, my company is focused, can you develop an app? So that's that's the base. That's like all our interviews are all around that. So basically we give you task, develop this app, and then we evaluate how well you can develop it. And yeah, that's it. And some other companies do like how good are you at algorithms and stuff, so you need to know that, uh, it really depends, like, what you do. Like for me, when your day-to-day work is like developing the apps, doing backends in Django for some web app or mobile app, or doing the web app or mobile app, or doing whatever, I should probably test you on that scale when you are applying for that job, that you are able to do your do your work basically, and then we are good. I don't need I don't need degree. I don't need much else. I need for you to be able to do your do your job. That you will do every day. That makes sense to me at least, but I know that not all the companies see it that way. Yeah, got it. Well, Docker, I would say for sure. Docker Compose is definitely a really nice tool for the development. Kubernetes is quite complicated, and it's more for DevOps role. Like if you really want to manage that infrastructure and everything with it, then yes. But otherwise, it's definitely not required for like everyday developer to know Kubernetes. It's Mhm. Yeah, yeah, that does. Yeah, for sure. Mhm. Yeah. Okay, cool. Got it. Oh, yeah. Well, in that case, you might consider also learning something about clouds because those Kubernetes clusters and stuff usually run in some cloud, and there are other services like AWS, Google Cloud, and stuff like that that like are really widely used. So yeah, you might be surprised. Yeah. I was just deploying last week. I was deploying the production infrastructure to AWS for one of our project. It took me like 4 days, and it was like prepared already. It was running on 3 different environments already, and it took me 4 days to prepare it for production. Just think. No, I exactly knew what I need to do and what needs to be done and what needs to be set up, and yeah, it still took me 4 days. Almost. And like I don't want to brag, but I think like most of the senior developers like wouldn't be able to do much of the stuff there. Like uh it's a DevOps job, and I'm lucky that I was doing DevOps and I was working with AWS before quite heavily, so I was able to do that. But by the way, also the reason I was doing that because that's a different story. But I'm like the engineering manager there. I don't usually do work on the projects, but colleague of mine like took a vacation for production release, but he took it like in February or March or something. Like he didn't know at that time that we will be releasing. So yeah, and basically it was like we can put there somebody like to replace him, but not for this. It was basically only one like able to do this available at the time. Yeah, yeah, yeah. That's doesn't even scratching our stuff. We have like 50 different services. Like we have two separate VPCs for organizations, which each of them has 7 subnets, and yeah, things like that. Only the networking for the project is like a small to middle-sized company networking. It's like a network with like 14 separate subnets that need like special routing rules between each other in the cloud. Yeah. It's just networking. We are not talking about any computation cluster scaling. There's like a lot of heavy data science stuff. There's click scraping, content management. There's real-time stuff chatting. There's queues, data storage, global image and video serving, video streaming with dynamic bit rates. There's like so much stuff in that project. It's one of the bigger ones. There's like 30 people on that, I think, and 10 of them is backend developers or something like that and stuff. Yeah. Yeah, AWS has a lot of services. Well, yeah, it's kind of different now. That's why we use Docker and clouds and stuff like that, because everything there is like managed, secure, can scale up easily and things like that. So yeah, and now you have all those services, so they try to market to. But you can still like run your own like VPSs somewhere on DigitalOcean or Linode or somewhere. That's fine.